There are 4 steps involved in CST processing. The first 3 steps occur concurrently. In step 1, the root bridge is elected. In step 2, the shortest path calculation occurs. In this, the root path cost for each node is calculated. In step 3, the port roles are assigned. As the first 3 steps occur concurrently, an interface's port role may change many times before convergence occurs. In step 4, all non-designated ports, not a root or designated port, are blocked. These ports remain blocked until they no longer receive superior BPDUs. This can happen if a link fails. In the next slide, let us understand common spanning tree convergence. Convergence time is the duration which the network takes to achieve stable operation after a disturbance. In a stable CST configuration, a switch continues to receive configuration BPDUs from the root bridge on its root port. 2 events signal a topology change. First, a port transitions to forwarding. Second, a port that was forwarding or learning transitions to blocking. For CST, using the default, convergence time is the sum of 20 seconds of max age, 15 seconds of listening, and 15 seconds of learning, making a total of 50 seconds. 50 seconds may not seem like a long time, but imagine you are updating a database interactively. Suddenly you have to wait for 50 seconds to receive a response. It will seem like a long time. The problem comes with real-time applications like teleconferencing. With a freeze frame of nearly a minute, most participants will assume that they have lost the connection. In the case of VoIP, the call will probably be timed out. CST's long convergence time has led to the development of STPs that converge more quickly, such as Rapid Spanning Tree Protocol, RSTP. Let us discuss RSTP in the next slide. In RSTP, there are 3 port states: discarding, learning, and forwarding. The disabled blocking and listening states of CST are replaced by a discarding state. In the following slide, let us look into how port roles have changed in RSTP. RSTP has 5 port roles. The root port, designated port, and disabled roles are the same as in CST. There are 2 new port roles. If the designated port fails, the alternate will step in. A backup port is like an alternate in a hub environment. Let us focus on RSTP convergence in the next slide. RSTP converges on a link-by-link basis. It looks at neighbors to determine whether to forward or block. It behaves differently depending on the type of link existing with its neighbors. The first link type is point-to-point, where communication is full duplex on the link. A shared link type uses half-duplex communication. Then there is an edge port. This port connects an end device to the switch. If configured with the port fast option, these link types generate topology changes when the port changes between a disabled or an enabled status. If an edge port is configured with the port fast option, then STP recalculation will not be required when the port changes between a disabled and an enabled status. However, if an RSTP edge port receives a BPDU, it reverts to point-to-point or shared link type. Let us continue this discussion in the next slide. Convergence is improved for edges and point-to-point links. There is no difference on shared links. In CST, convergence waits on the hello, max age, and forward delay timers. RSTP waits on timers to expire as CST does. It only has to wait 3 times the hello time, which defaults to 3 times 2 seconds equals 6 seconds for convergence. This is an improvement over the 50 seconds convergence time for CST. Note in RSTP, only non-edge ports that move to the forwarding state can cause a topology change. Let us learn more about the port fast option in the next slide.